In the previous video, we saw what types of AI are applied in a photovoltaic project. But now let's get down to the operational level. Where does the data come from? What software does it use to process it? And where are these AI algorithms executed? This slide summarizes the entire ecosystem: data, platforms, and devices that make up the digital brain of the photovoltaic project. It all starts with data. And in photovoltaic projects, we have multiple essential sources, such as satellite and drone images, key for site and construction analysis, meteorological and irradiance data, BM models, with technical specifications, and increasingly, automated inspection reports, thermography, IV curves, etc. The quality of this data directly determines the accuracy of the AI. Once the data is captured, we move it to the software that processes it. For photovoltaic design, tools such as PV-Syst Plus, Helio AI, and SAM 2.0 stand out, enabling performance simulation, P50/P90 analysis, and optimization. For construction and execution, Procore, Autodesk, and Drone Maps, which integrate AI for planning, modeling, image analysis, and progress monitoring. As a project manager, your work increasingly relies on dashboards that unify this type of information to make informed decisions in real time. In the upper right corner, we have a very important comparison. AI in the cloud is used for complex tasks, large volume analysis, multi-criteria simulations, advanced design. It is ideal for the design, pre-construction, and planning phases. On the other hand, AI at the edge runs locally on devices such as drones, cameras, or sensors. It is fast, responds in real time, works without constant connectivity, and is key for field inspection and safety. The current trend is a hybrid architecture. Combining both technologies. AI embedded in field tools is another qualitative leap. We now have AI directly embedded in construction devices, such as smart thermal imaging cameras that detect hot spots and automatically generate alerts. Autonomous drones that inspect structures and compare them against the digital model. AI-powered IV analyzers that compare curves against patterns to detect faults. And augmented reality tablets that help operators validate execution in the field. This allows for a level of control and traceability that was previously only possible in post-construction audit phases. Below is a simplified diagram summarizing the ideal flow: data capture from the field, or design. Pre-processing and cleaning. Analysis, using AI-powered platforms. Output, decisions for the project manager, recommendations, optimization, or alerts. As you can see, to effectively apply AI, it's not enough to have the algorithm. You need a network of sensors, clean data, specialized software, and well-integrated edge cloud capabilities. And once we have this infrastructure up and running, how do we use it to improve the design and technical and financial feasibility of the project? Now it's time to look at its direct impact on what matters most to us as PMs: technical design, energy efficiency, and of course, the project's economic viability. This slide summarizes how AI helps maximize production, reduce LCOE, and optimize decisions from the very beginning of development. AI no longer chooses visually promising sites. Today, it works with integrated data layers that analyze parameters such as historical irradiance, environmental constraints, topography, and, critically, proximity and ease of connection to the grid. This improves initial selection, reduces uncertainty, and speeds up permitting. For optimal PV plant design. This is where AI has the greatest impact, as it calculates the optimal layout between rows, orientation, and inclination. It suggests the best combination of technologies: modules, inverters, and trackers. And it can simulate dozens of combinations in minutes, which previously took weeks of manual work. The screenshot shows how AI optimization software automatically adjusts modules to maximize annual irradiance. A simple layout adjustment can increase production by up to 7.3%. In the lower left graph, we can see an LCOE comparison of traditional design versus AI. This graph is key for presentations to management and investors. It shows how, year after year, AI-optimized designs have managed to reduce the average LCOE from more than €7 per megawatt hour in 2020 to less than €5 per megawatt hour in 2025. The message is very clear. Good AI design saves millions over the life of the plant. Traditionally, comma shading was estimated with static tools. Today, AI with deep learning models shadows based on the time of day, season, and real-world environment, even with moving elements. The result we can achieve is that shading losses can be reduced by up to 15% of annual production. In interconnection optimization, AI can also optimize electrical design, such as sizing substations, optimizing cable routes, simulating network events, and automatically verifying compliance with electrical codes. This has led to a cost reduction of 8 to 12% in interconnection alone, according to several recent studies. As you can see, this is one of the areas where AI provides the most tangible and quantifiable value, both technically and economically. More precise designs with higher production, lower LCOE, and better bankability. Next, we'll see how AI not only designs better, but also improves the construction and commissioning of photovoltaic plants. The construction phase remains one of the most critical moments for any project manager. Delays, installation errors, and commissioning failures have a direct impact on the project's schedule, and ROI. Artificial intelligence is transforming this phase, making it a much more controlled, efficient, and predictable process. Thanks to the use of computer vision, drones can capture images and compare them in real time with the project's BIM model. This allows for automatic validation of the actual percentage of progress on structures and modules. Updating digital twins with actual physical progress. And generating alerts when progress falls short of plan. On site, early detection of deviations is very important, and this is where AI can provide the most operational value, such as detecting structural alignment errors, improperly assembled modules, or faulty connections. It can verify wiring patterns and detect dangerous or incorrect configurations. It also generates safety alerts on site before an accident occurs. Regarding logistics, AI is capable of anticipating material and equipment needs based on the actual progress of the project. This avoids cost overruns due to incorrect logistics, excess stock on site, or lack of supplies. During commissioning, AI can automate IV curve analysis, evaluation of thermographic data, detection of anomalies in the plant's initial performance. This ensures faster and more accurate commissioning, with fewer undetected errors. All these processes generate data that is displayed on dashboards like the one shown on the screen, where we can quickly see some KPIs, such as total progress, structure assembly, module installation. Quality, safety, and delivery prediction. Even efficiency in the use of human and material resources. These are live metrics that, as a PM, you can consult daily and use for internal or external reports. You can compare these real-world project parameters with the project's planned progress to determine its evolution and see at a glance where things are improving or worsening, so you can later analyze each of the causes in detail. This allows us to have greater traceability across the entire project. Some examples of these KPIs that can be measured include construction times, logistics costs, etc. As you can see, AI on construction sites is no longer a future trend. It's a real tool for reducing uncertainty, improving quality, and accelerating project delivery. Next, we'll see how this same AI allows for better management of risks, quality, and all the technical documentation associated with the project. Managing risks, maintaining high-quality standards, and maintaining complete technical documentation is not only an operational burden, it is a legal, financial, and contractual responsibility. And in this sense, AI is also proving to be a decisive ally. In risk identification and prediction, for example, AI can analyze thousands of historical data from schedules, budgets, quality reports, or production. With this, it can predict delays based on patterns of previous progress on other projects. Detect the risk of cost overruns with simulations of economic deviations. Evaluate the quality of execution based on inspection and sensor data. And simulate future performance, comparing it with defined production targets. In quality control, we enter a practical field where, for example, AI analyzes images of modules before installation to identify microcracks or manufacturing defects. It verifies welds and connections with computer vision with accuracy of 99.8% during assembly. It monitors in real time with smart cameras and self-learning systems. Finally, it generates defect statistics, facilitating immediate corrective actions. Document management is highly valued by project managers, allowing for automatic extraction of key data from contracts, technical sheets, and licenses. Verifies regulatory compliance. And generates professionally structured progress and inspection reports. This significantly reduces the time spent on repetitive tasks and improves document traceability. On the right, we can see two real-life examples: an AI-enhanced risk matrix, which automatically classifies according to impact and probability. It does this by integrating project, budget, and quality data. And an AI-generated quality report with structural validation, connection verification, module orientation, and IV testing, all digitally signed. These types of reports are already being used to audit specific sectors and reduce manual reviews. With this, we can achieve, for example, more than 82% in early risk detection. Reduce document management time by 68%. Increase quality control accuracy by 95%. These results not only improve internal KPIs, but also increase the confidence of banks and investors. As you've seen so far, AI is no longer just a tool for improving technical efficiency. It's also a guarantee of quality, compliance, and traceability, something fundamental in large-scale projects that objectively improves project progress when integrated from the outset as an additional tool. In the following video, we'll see how the plant's actual performance is ensured and how the transition to operation and maintenance is prepared with AI-enriched digital twins.